All right, take two. I did this whole lesson and forgot to record it, so hopefully you can hear my voice right now. And it's lo-fi. Today we're going to talk about solving quadratics by factoring. Okay, so we spent a large chunk of last unit going over how to factor polynomials. So now we're just going to use those skills to then solve quadratics, okay? And so this all boils down to what we call the zero product property. And it's pretty straightforward. It states that if A times B is equal to 0, if the product of A and B is equal to 0, then A equals 0 or B equals 0, right? And we know this to be true, that the only way for the product of two things to equal 0 is if at least one of those factors is equal to 0. Okay, so let's look here. Let's consider the following quadratic function. F of x equals x minus 3 times x plus 7, right? And you just spent yesterday kind of exploring quadratics written in this form, in this factored form, and how it relates to your graph, which we'll touch on. But we know that this is quadratic because if we were to expand this, this would give us a quadratic trinomial, right? This is the equivalent of x squared plus 4x minus 21, okay? So we're asked, what are the solutions to the following quadratic equation? Well, when we're asked to find the solution, the word solution, the term solution, is interchangeable with what we call our zeros, with the word zeros, our roots of a function, which are really our x-intercepts, okay? They are the points on the graph where the y value, where your output, is equal to 0. So we're setting this equation equal to 0, and now we're going to solve this equation. We're going to solve this using the zero product property because in factored form, we have a product of two things, right? We have this x minus 3, which let's say in this case is our a. So if x minus 3 times x plus 7, or b, is equal to 0, then either b is equal to 0 or a is equal to 0, right? And so that means that either x minus 3 has to equal 0 or x plus 7 must equal 0. So if I solve for each of these x values, I get x equals 3, and here I get x equals negative 7, right? And you might have noticed this on your graphs yesterday, that when you saw something written in this form, there was this kind of inverse relation between, if I saw an x minus 3, my x-intercept was at a positive 3. And if I saw an x plus 7, my x-intercept would be on negative 7, right? And so these are our two solutions. So let's graph this on the right. 3 and negative 7 right here. Okay. And so the next question is, now knowing this, let's find the axis of symmetry and the vertex of this function. Okay. And so when we're given something in standard form, for instance, we would use for axis of symmetry negative b over 2a, right? X equals negative b over 2a. In this case, this is negative 4 over 2 times 1, which is going to be equal to negative 2. But when we're given something in factored form and we've already found the zeros, we also know that because quadratics are symmetrical, that our 0 has to fall right in the middle, which is at negative 2, right? And so without even doing negative b over 2a, we can find our axis of symmetry if we understand that we have a symmetric graph, okay? So my axis of symmetry here is at x equals negative 2. To find my vertex, then, I need to input that negative 2. Okay, so because we already have our function in factored form, let's go ahead and just plug it in to negative 2 x minus 3 times negative 2 plus 7, right? This is going to give me negative 5 times positive 5, which equals negative 25. So my vertex is on the axis of symmetry at negative 2, negative 25. Okay, this isn't going to actually fit on our graph, but let's just say this point right here is negative 2, negative 25, and we can start to see our graph, the parabola. Okay. Like I said, zeros are here. Axis of symmetry is right in the middle of our two zeros. So this is helpful now, right? If I want to solve any quadratic, if I can factor the quadratic, I can easily find the zeros. So let's look at another quadratic equation in factored form. We have 2x minus 1 times 3x plus 8. So following the zero product property, the 2x minus 1 is equal to 0, or my 3x plus 8. So if 2x minus 1 equals 0, we're going to add 1. Get 2x equals 1 divided by 2. X equals 1/2. Solving this one, 3x plus 8 equals 0. Subtract 8, we get 3x is equal to negative 8. Dividing by 3, we see that x is equal to negative 8 thirds. Right, and these are our two solutions here. All right, so what if we have a quadratic function that we're trying to solve that isn't in factored form? Correct, we can factor it, right? And so we have a GCF here of x. So I factor out an x, I get x times x minus 5 equals to 0, right? So even though one of my factors is a single x, this is still technically a product, so I could still apply the zero product property, the ZPP. So x equals 0 straight up, or x minus 5 equals 0, which means x is equal to 5. Okay, so my two solutions here are x is equal to 0 and 5, right? And just by looking at this, hopefully you're starting to see, like, you can pick up on, okay, a positive a value, this parabola is going to open upwards. My zeros are at 0 and 5, so this parabola is going to be centered at 2.5, right, in the middle. Okay, cool. Now, example C, we have an equation that isn't equal to 0, right? For all of these, to solve this, if I want to apply the zero product property, the product has to be equal to 0, right? So in this case, when we have an equation where we don't have 0, we can just go ahead and make a 0, okay? And so I'm going to just take this and move it over. We're going to take that 2x squared. I'm going to add it to both sides of my equation, which gives me 0 is equal to 2x squared minus 12x plus 18. I'm putting the 12x first because I want it in standard form. Now let's factor this, right? Now remember, before we factor anything, or the first step, the first thing we check for when factoring is a GCF. And we see here that we have a GCF of 2. We get x squared minus 6x plus 9. Then we can go ahead and figure out, hey, what's going to give me a product of 9 and a sum of negative 6? That'll work, but if we look closer, this is actually a perfect square trinomial, right? This is a perfect square. Perfect square trinomial. It follows that pattern. Remember, a squared minus 2ab plus b squared? So we can actually just go ahead and factor that as 0 equals 2 times x minus 3 squared. So what does that mean? That means we only have one solution, right? Because I have 2 times 0. This has to equal 0 for this product to equal 0. So x minus 3 equals 0. Therefore, x is equal to 3. So is this okay? Like, what does this mean, right? All of these previous examples we saw had 2 solutions. So if I have one solution, that means that this graph only has one x-intercept. So what would a graph of a parabola look like if it only had one x-intercept? Let me make some room here. It might look something like this, right? If I have say this is our graph. That means at x equals 3, I have an x-intercept, right? And if that's the only place it goes, that means this solution is also the vertex of the graph. I'm actually going to do it in green. And it's going to open upward somewhat like this, okay? So we can have 2 solutions, 2 x-intercepts, 2 zeros, 1 0. And there's also a case where we have no solutions or no x-intercepts, right? And that would be something like this. If I had, let's say, a vertex that was above the x-axis and my graph opened upwards, this parabola will never hit the x-axis. We'll never have any solutions. This is an example of no solutions. Okay. All right, let's look at this one last application and then we'll wrap it up. So the height of a diver above water during a dive can be modeled by the equation h equals negative 16t squared plus 8t plus 48, where h is the height above the water in feet and t is the time in seconds. Find the time it takes for the diver to reach the water. So if the diver is reaching the water, that means the height is what? 0, right? So this is asking us to find the zeros. How long is it taking? So let's say my diver, say this is our diving board. I know that my diver is 48 feet above the water. Okay. And assuming that this path is a parabola, right? Let's say this would be like my water or my x-axis. Oh gosh. Okay. So we're looking for, hey, what is this t value? What is this value of time when my height is 0, right? Imagine this is like the x-axis of your graph. This is our y-axis, right? I'm just going to move them over a little bit. Yeah, like that. Okay. This is for starting height of 48. So we need to find when h is equal to 0. So I'm going to go ahead and set this up. 0 equals negative 16t squared plus 8t plus 48. So now to solve for this solution, we just need to factor this quadratic. So we get 0 equals, we have a GCF of 8. We can get negative 2t squared plus t plus 6. Okay, this is where that review comes in. We have a coefficient that isn't 1. So this is the case where we have to do a product of AC, right? A times C, which is negative 12. In this case, negative 2 times 6. We want a sum of positive 1, right? Because this coefficient is 1. And those numbers are going to be negative 3 times 4 is negative 12. Negative 3 plus 4 is equal to 1, right? We're going to use these numbers to split up this polynomial. So we get 8, 0 is equal to 8 times negative 2t squared minus 3t plus 4t plus 6, right? We take that t and split it up so that we can factor by grouping. So we're going to factor these two and then these two. I know that these are both negative and these are both positive, so I'm going to factor out a GCF here of negative t. Bring on a negative t. I'm going to be left with a positive 2t plus 3. When I factor out my GCF here of 2, I'm also left with a 2t plus 3, which means that if I factor out the 2t plus 3, I'm left with a negative t plus 2. And I also can't forget that 8. And we're trying to solve this when this is equal to 0, okay? So now I have 3 factors, but still a product must be equal to 0, then one of those factors must be 0. 8 can't be 0, but I'm going to solve when these two are 0. So let's move this up over here. If 0 is equal to 8 times 2t plus 3 times negative t plus 2, we're going to then split these up, right? So 2t plus 3 equals 0. Negative t plus 2 equals 0. This is going to give me negative 3 equals 2t. I get t is negative 3 over 2. And here, if I subtract 2, I get negative t is equal to negative 2. Dividing by negative 1, we get t equals 2. So we've gone ahead and solved for when my height is 0, and I get 2 answers. 2 different values of time, which technically shouldn't be possible, right? I can't jump off the diving board and then hit the water at 2 different points in time. And if we really think about this, I can't really have, in this context, a negative value of time, right? So in this scenario, t can't be negative. So I know that my answer is 2 seconds. Okay. But that begs the question, hey, why is this t here anyways, right? And that's because we're already starting at a height of 48, right? If I were to extend this parabola to the left, right, I can, this, like, the parabola itself has 2 zeros, right? This is where t is negative 3 over 2. It just isn't applicable in this application, right, in this context. So the answer we want is that t equals 2. So diver hits water after 2 seconds. So a lot of the algebraic skill here used to solve these is all stuff you've been doing, right? We spent all that time factoring polynomials, right? You've been solving equations since 7th grade, right? And so a lot of these equations aren't difficult to solve. We're just now like bringing them all together under the context of solving a quadratic equation, okay? I'll have a copy of these notes uploaded and a blank as well for you to follow along with. Please let me know if you have any